know that first rule of logic everyone learns, that everything is either true or false, black or white? Well, get ready because we're about to dive into a paper that says that's not the whole story, not even close. It turns out the truth is way, way fuzzier. And understanding that fuzziness, well, that could change absolutely everything. I mean, just think about your own life for a second. If someone asks if you're happy, is that a simple yes or no? Of course not. It's complicated, right? We're constantly trying to cram our reality into these neat little true or false boxes, but life, it just doesn't work like that. So this all boils down to two totally different ways of thinking about logic. On the one hand, you have classical logic. Think of it like a simple on-off light switch. It's either true or it's false. That's it. But then you have many-valued logic, and that's not a switch. It's a dimmer. It allows for all those shades in between. Mostly true, kind of false, maybe. It's a logic that's actually built for the messy world we all live in. All right, so let's explore this hidden spectrum, because it's not just some abstract idea, it's the actual language of nuance. And look, this isn't just some vague philosophical concept. We're talking about a real, formal mathematical system here. It's not about adding just one or two more options between true and false. No, this opens the door to an infinite number of truth values. It gives logic the power to actually handle things like doubt, uncertainty, and all those shades of meaning that we use every single day when we talk. And once you start thinking this way, you see the failures of that old binary logic everywhere. Is a slightly orange tomato just not red, or is it mostly red? Is a self-driving car's decision simply safe or unsafe? Or are there, degrees of risk? Our world is just packed with these gray areas, and a simple true or false system just can't compute. And this brings us to the big problem, the central conflict of our story. This nuanced, powerful logic is great for us, for describing the real world. But our computers, our AI, our entire digital infrastructure, it's all built on that simple on-off switch of ones and zeros. So how do we bridge that massive gap? This became the huge challenge for researchers. How on earth do you translate a fuzzy human concept like maybe into the perfectly precise, cold, hard language of mathematics that a computer needs to actually function? It seems almost impossible, doesn't it? What the field really needed was essentially a kind of universal translator, like out of Star Trek, a rock-solid, mathematically proven bridge that could connect our complex, fuzzy world to the structured, binary world of machines without losing all that crucial nuance in the process. And this is exactly where the paper we're looking at today comes into the picture. A team of researchers, Cecilia Britz, Willem Condrati, and Will Murray Morton, they did it. They actually developed the breakthrough needed to build that bridge. They created an algorithm that acts as this universal translator. And their approach was just brilliant. Instead of starting from scratch, they took these powerful tools that already existed in classical logic and just cleverly adopted them. First, they took something called Salquist theory. You can think of it like a master blueprint for logic, and they stretched it to work in this new fuzzy setting. Then, they repurposed this powerful algorithm called ALBA to act as the engine for the translation. And what they got was a reliable, proven method to finally bridge these two worlds. But, and here's where the story gets really good, in the process of building this bridge, they stumbled onto something completely unexpected, something that shocked even the experts and revealed a much, much deeper connection between the old logic and the new one. So here's the key finding, simplified a bit from the paper. They discovered that for a huge, really important group of logical formulas, those Salquist formulas, the translation from the new fuzzy logic looked exactly the same as the translation from the old black and white logic. Just think about how wild that is for a second. After building this entire sophisticated bridge to a new world of logic, they looked at the blueprints and realized that for the most important structures, nothing had changed. The old rules, the black and white rules, were secretly powering the fuzzy logic all along. Let's take a basic logical rule like reflexivity, the idea that everything is related to itself. In the old black and white logic, its mathematical formula looks like this. Now, everyone expected the formula for the new fuzzy logic to be way more complicated, but it wasn't. It was identical. The foundation was the same, whether you're using a light switch or a dimmer. So, okay, this is a totally mind-bending discovery for logicians. But what does it mean for the rest of us? Why does this matter?
because it turns out this surprising connection is what actually builds the bridge to our future.
This breakthrough unlocks a future that we've really only seen in science fiction. Imagine an AI that doesn't just give you a yes or no answer, but can say, I'm about 75% certain. Imagine safer self-driving cars and more accurate medical diagnoses, all because they're no longer forced to see the world in black and white. For the first time, we have a mathematically proven bridge for machines to reason about the world the way we do, in all of its messy, uncertain glory. This whole journey started just by questioning a simple on-off switch and discovering this hidden spectrum. It really makes you wonder, doesn't it? What other black and white rules that we live by are just waiting for us to find the dimmer switch?